Hey, this is Alex Hackett, and today I'll be giving a presentation on atoms and bonding. So the atomic, or basic atomic structure is as follows, and I will be talking more specifically about carbon. So in the center of an atom, there is a nucleus. The nucleus is the area that contains protons, or the parts of an atom that make it have a positive charge. There are also neutrons. Neutrons are the parts of the atom that actually don't have a positive or a negative charge. They just add to the weight. And in this particular atom, there are 6 protons and 6 neutrons, and when added together, you get the weight of 12, an atomic weight of 12. And by definition, atoms do not have a positive or negative charge, and this is why there are 6 electrons to balance out those 6 protons with the positive charge, as seen here. Here's an example of one. Now, we're going to move on to isotopes, but I first want to mention, before I talk about what an isotope is, that in this first ring here, which is closest to the nucleus, that can hold 2 electrons at a time, as that's its maximum capacity. And then the second ring that's next to that can hold up to 8, just like the one that would be, kind of make an imaginary ring out of that. That one more ring out here would be able to hold 8, and then yet another one, which would be, let's see, the fourth one out. If there were a fourth ring out here, that would be able to hold 18 electrons. Those are its maximum capacities. Now, an isotope, in an isotope, the only difference between an isotope and a regular atom is that this form of it has more or less neutrons than what are most commonly found. The only big difference that this makes is that it changes the weight. The atomic weight in this atom is more than it was before in the other version. Now, ions. So for this example, I'm going to be talking about a different type of ion or atom, and this is, let's see, this is sodium. So sodium has 1 electron, or imagine 1 electron in this outer ring. But when it loses it to chloride or chlorine, and then which becomes chloride, it becomes an ion, because an ion is an atom that has lost or gained an electron from its standard form, and that's what makes it have a positive or a negative charge. Now, here we see sodium again and chloride, and this is what they look like after they have lost an electron. And so the reason why sodium has lost an electron in the first place and chlorine gained it is because atoms are most happy, and more specifically most stable, when all of their electron shells are filled up with electrons, no room left. And so, and this is called the octet rule. And this is, and the reason why sodium wanted to lose an electron in the first place is it's because it's easier for it to lose an electron than it is for it to gain 7 more to fill up that shell. Now, after this process happens, these 2 ions have positive and negative charges, and these opposite charges attract each other, and that's what makes this bond between sodium and chloride, and that's what we know as table salt. That's the chemical reaction that comes out of that. Now, covalent bonds are a little different. Covalent bonds are, as seen here, this is CO2, 1 carbon in the middle and 2 oxygen on either side. Covalent bonds are bonds that share the electrons between the different atoms more evenly. So in this case, the atoms are looking for the same thing. They're looking to fill their shells up, but they share the electrons. Carbon is sharing its electrons with oxygen. Oxygen is sharing its electrons, or some of its electrons, with carbon. And at the end of this reaction, all of the atoms are pretty much happy as happy as they can be, because they all have filled electron shells, even though they're sharing with each other. Now, water's polarity. This is H2O, which is water, and in this example, we can see how oxygen is sharing its electrons with hydrogen. However, oxygen is more hungry for electrons, so the electrons are drawn closer to the oxygen atom, than they are to the hydrogen atom. And this makes oxygen have a slight negative charge, and the ends of the hydrogen part of the molecule have a slight positive charge. Now, This is important because this is what makes atoms, this is what makes water such a good solution for dissolving other substances like salt or sugar because because of its polarity, it can bond with other substances and kind of break them apart. And that's what dissolves them. That's what we know about dissolving. Here it is up close. Now, pH or acidity is measured on a scale from 1 to 14. 14 being the most basic, 1 being the most acidic. 7, which is in the middle, is the most, or it is neutral. And water that we drink is almost, it's usually around 7. Now, you would think, well, maybe the difference between 1 and 14 is probably not that much, but it really is because the difference between just one of these numbers, say between 3 and 4 or 5 and 6, it's on a logarithmic scale, which means that the difference between those two numbers right next to each other is an order of magnitude. They are 10 times bigger than the previous or 10 times smaller than the one in front of it. Now, what makes on a molecular level, what's actually the science behind it is that when there are more protons in water, the water is more acidic. So, as seen here, there are more plus, or there are more protons than there are what are called hydroxide molecules, and this is when the water molecules are split apart and you get H plus, which is like just the hydrogen atom without its electron, which is just a proton since it only has one electron in the first place. And when its most basic form at a level of 14, there are more hydroxide molecules than there are protons. Now the reason why this is so important is because the amount of how acidic something is crucial to the health of organisms on this planet. So, for instance, if you can imagine if rainwater happened to be at a level of like 2 or 1, it would be like stomach acid flying from the sky. It would it would burn through things, and it would be a complete disaster. Maybe a more practical analogy would be if you have a fish in your house, one of the things that you have to keep track of is the acidity of the water in the fish tank, because that acidity, if it varies too much from what the fish is used to living in its natural environment, can kill the fish.